Welcome to my channel EasyML. In this video, we will see how principal components are built. Let us now inspect how variables are mathematically combined to form principal components. It is important for you to note that the number of principal components calculated will be equal to the number of variables. Here, you can see that I have three principal components. That is because I have three variables, that is height, weight, and age. Note that for the purpose of this example, I will deem height as my first variable, weight as my second variable, and age as my third variable. A portion of height, weight, and age will be loaded into each of these principal components. In order to understand a little bit more about this loading process, let me introduce the concept of weights. Here I have weight ij, where I is the number of the principal component and j is the number of the variable. So essentially these weights are what portion of variable j is loaded into principal component I. Let us now take a few examples. Here I have W11. The first one, that is I is equal to 1, stands for principal component 1 or PC1. And the second one, that is j is equal to 1, stands for height. As amongst height, weight, and age, height happens to be the first variable. Hence, weight W11 suggests how much of height or what portion of height is loaded into the first principal component. Now let us take a look at another example. Let us see what W23 means. Here, I is equal to 2 stands for the second principal component, that is PC2. And j is equal to 3 stands for age, as age happens to be the third variable here. Hence, W23 suggests how much or what portion of age is loaded into PC2. Now, let us take a look at yet another example, W32. Here, I is equal to 3 and this stands for the third principal component or PC3, and j is equal to 2. This stands for the second variable, that is weight. Therefore, W32 suggests how much of weight is loaded into PC3. Conclusively, a portion of height, weight, and age is loaded into each of these principal components, and the portion is determined by the weights. In these calculations, the weights are calculated such that the principal components are independent of one another. Recall, that was the aim of PCA, that is to convert linearly correlated variables into new uncorrelated variables. And the second aim or the second reason as to how the weights are calculated is to ensure that the principal components capture the essence of all the variables. Note that these 2 points are extremely important as they will help evaluate principal component analysis. We will see more about this in the next video. Thank you. Stay tuned.